for TripAdvisor, but I'm allowed to show slides because my presentation is not about TripAdvisor. Satish and I, we went to the HackReduce 3 that was conducted at the same venue as we are here today, and we were given access to 600 Hadoop nodes, and I think about 80 developers showed up and paired up in teams. And for us, it was we didn't know, we hadn't written any Hadoop programs. It was the first time we were getting access to a Hadoop cluster. So we went there with an idea of visualizing search results. So I'm gonna show you what we did and then how we did it, and maybe give you a snapshot of a demo. So also the application that we developed, we called it Wikipedia Tag Clouds, and at the end of the day, it was voted as the coolest application by the audience. We did not hack the poll. So what is Wikipedia Tag Cloud? So our basic idea was that it's kind of like a search engine. You take a word, and we would take a word, we would search Wikipedia for the presence of that word. Traditional search engines will show you the top 10 most relevant results at a time, but we wanted to show every single result to the user on the same page. So by that, what I mean is that we would go through every single result in the entire Wikipedia. It could be 1 million pages that were hit, and we would crunch data from all the pages and summarize it on one page as a tag cloud. Our result would not be URLs that would take you back to the pages, but it would be related words. So let's see a demo. It's not a live demo, but a screenshot that we took. So we fed the word Obama to Wikipedia, and this is what came up. So if you're familiar with the tag cloud, you know that things which are more important, which have higher relative importance, are shown in the bigger font size. So it's we can see that the word Barack has the biggest font size, indicating a very high correlation and a very high relevance to the word Obama. Now, how we determine relevance is something that we are going to go in the next few slides. Some of the other words which are important are president, United States, campaign, and so on. Just to be fair, let's take another example. Take Romney this time. So any guesses what might show up? All right, there you go. So no surprise that Mitt is the biggest one. Some of the other words which are shown as relevant are McCain, Giuliani, Governor, Massachusetts. Undecided, I'm very curious. Why Mitt Romney? Is Mitt Romney undecided? I thought Kerry was the one. So looks like this was a very important step for us when we were trying to implement it. As a couple of earlier speakers pointed out, that it's very useful to first take a small data set, start with a small data set, go for an algorithm which represents your heuristics or hypothesis, and test it out. So something like this was very important for us because it gave us a hint whether our algorithm is working correctly or not. And we had to make a few tweaks, but they were mostly related with stock words. Words like, the typical stop words, we kind of forgot to remove them in the first iteration, and then we noticed that some of the stop words were in very big font size. Now let's dive a little bit deeper into how did we do this. So first step is getting the data, and then I'm going to go into the algorithm part. This, from one of the earlier slides, I've now learned is actually small data, and large data smalls from terabytes. So I didn't have time to change the slides, but 31 gigabytes, and we are doing a free text search on 31 gigabytes, and our program took about 4 minutes for a word. So it's still 100,000, scanning 100,000 pages, and technically that's just the map phase. So it's probably actually runs 150,000 per second, which is pretty fast. You don't want to run something straight in a Java program on your laptop. So you can download the entire Wikipedia as a single XML file download. It unzips to 31 gigabytes, does not include history. If you really want the full data set, it's about 3 terabytes, contains the full history. If you open the XML file, which you don't want to do in Notepad, you will see that there is a root tag called MediaWiki, and then that root tag contains 25 million child tags called page. So that's how they've decided to organize their data for some reason. So people who are familiar with Hadoop know that you can take a large data file and pass it to Hadoop, and by default Hadoop will read it line by line and sort of process each line in parallel. But it also gives you a way to specify how to do the line breaking. So we kind of had a program which split it by this page tag. So the algorithm is actually quite simple, and again something that some speakers pointed out, that big data doesn't really mean complex algorithms. You can do fun things by a very simple algorithm. So we scan all Wikipedia pages, and we look for the presence of the base word in each page. If we don't find a page, if we don't find the base word in the page, then we skip that page and go to the next one. If we do find the base word in the page, then we look for all related words which are close to the base word. And I'll go into a little bit more detail later. Then we score those related words. And at the end, we pick the ones with the highest score, because you don't want to show 300 million words to the user in a page. So we pick the top 50 words and show them as a tag cloud. So let's say we are scanning all the pages and we hit a page which actually contains the word that we are looking for. So note that the base word that we are looking for, Obama in this case, can appear at multiple locations. In fact, it is quite common that if a word occurs, it occurs in many locations on that page. For each occurrence of the word, we then look for other words close to that base word, and this is one of those heuristics that we used, that words which are near should get a higher weightage, and words become less relevant as you move farther down, and it's one of the things that you can also tweak and play with. We then capture all the related words along with the distance. So essentially, doing this activity generates a lot of data. So it might generate like 1 billion data points, because you are capturing every location of the word that you were looking for and all the related words and capturing the distance information. We then feed this data, we collect all of this data, and then the last step is how do we take this data and crunch it together so that we can score all these words, and then finally feed it to a tag cloud program. So Satish is going to talk more about how we use MapReduce to crunch that data.
So I think just going back one more slide, if you look at the words, you can see the distance from the base word. So for example, president is at a distance of 2, and 44th is at a distance of 1, ignoring the stop words. So this is kind of each page. The map phase looks at every single page which is fed as a record, and the output of that is each keyword with certain attributes, and maybe we can look at it here with some more detail. So let's take one example. The same, our base word is still Obama, but take some. If you look at each page tag, let's say it's a different article, and let's look at the word McCain just to focus on one example. And the output of the map phase is essentially spitting out, McCain at a distance of 5 in the first article, then McCain at a distance of 10, and then again at a distance of 8 from the base word in the second article. So at the end of the map phase, you have every single keyword in the document that contains the base word with a distance. And to the reduce phase, if you again look at McCain, we are passing all the data points for that keyword to the reduce phase. So, and this happens for every single keyword which is found along with the base word in the document. And at this point, you have your data, and now with using the data points, you can use any kind of formula or algorithm you want to actually come up with a score with those data points. So the algorithm which we used is it's a really simple one where we just gave weightage to the distance. We could have done a lot of things like if we collected multiple data points in the map face, they could all be passed as inputs, and our algorithms could actually make use of all that. So we've tried a few variations of this, but this is just a really simple algorithm where it's, if you're less than 10 words away from the base word, you get a certain score. As you move, say, away 40 plus words, then the weightage goes down quite a bit. So there are a lot of variations that can be done to the base algorithm. For example, all we did is we took the distance of the keywords from the base word, but we could certainly look at words which are closer to the top of the article, and you could make a case that words that are at the beginning of the article are way more important than those that go at the bottom. Looking at sentence boundaries, paragraph boundaries, looking at whether the word is, you hit the word going forward or going backward in a sentence. So there's a lot of different ways in which you can quantify relevance or distance, and these are all things that can be tried. So let's just look at a couple of more examples, and here we'll do it the reverse way. You can guess what the base word might have been based on this. Any guesses? Here you go. And here's one more. Thanksgiving. Turkey and the football. All right. So some of the other things we could do with in the same problem is look at a wider data set. We looked at Wikipedia, but we can certainly look at news articles, books, any source of data. Now at the end of this, we came up with about 50 relevant words or most relevant words. What we could also do is look at each of those words that were closest and then repeat the exercise for each of those words and see if some of them come back to the base word. And using that, we could maybe look at if certain words are in a cluster and find what kind of category brings them together. The last one is simpler than it sounds, because if we are going to do an API kind of thing, then you need immediate response, which is not exactly easy to do using Hadoop in real time. So the takeaways for us from this whole experience was that we created this, as we mentioned, in a few hours in the event. And big data doesn't necessarily mean that you have to build some big complicated apps to use it. I mean, if you have an idea and your only constraint is that you want to analyze some data, there are certainly tools out there that can help you try out your ideas. And because MapReduce and Hadoop make some of the plumbing relatively simpler, so you can actually focus more on trying out different variations of your algorithm or whatever it is you want to do, and kind of not worry about crunching all this data. So that's kind of it. Thank you.
Congratulations, it's fantastic that you can get up to speed on this new system within a day and do this demos. That's very impressive. The bigger picture, though, when you're not doing this as a one-day project, the question I have here is, it seems to me that if you use one of Doug Cutting's previous technologies, like C or some other system, you could have indexed the whole thing in under 4 minutes on a 600 cluster, and then had sub-second response on each individual query instead of 4-minute response. So when is this approach going to be viable? Not as a demo, which I think is really impressive. Speaking of your skills, really But when is this sort of thing going to be useful in a non-demo environment?
I think one of the differences is that here we are looking at multiple data points, like, so say for example, distance from the beginning of an article or distance from the beginning of a sentence. If you want to use all those multiple data points and come up with a score, it's a little more than just indexing, right? So that's where, and that's probably one difference.
So I have wondered about the same thing myself. Very, very fair point. I've wondered about that what would be the difference, and right now I don't know the answer to that, but I have been thinking about this, especially in the context of a possible website or a JSON service that we would like to build. I think one difference might be that I'm not sure if it would be feasible if you were to index everything in Lucene or Solr. Not sure if it would be feasible to look at every single occurrence and then look at everything around that in real time.
Sure.
Maybe we should have a one-day hackathon on Lucene and see.
Yeah, so that's a good point, though.
How long did it take you to feed a 2 gigabyte data?
So for us, the data was preloaded. So Hopper, Juiced is right there. Hopper was the company who was really helped us on the Hack Reduce day to get us started. And maybe you have an answer.
Sorry, I missed the question.
The question was, how long did it take to feed the 31 gigabytes of Wikipedia data to HDFS?
I don't know. I can't tell you that offhand. There's the time, obviously, of uploading it to Amazon, which is restricted by your internet connection, because we were running our cluster on Amazon. And then there's the time for Hadoop to distribute the data to all of the nodes, or rather to distribute, the segments of the data to the nodes. But I can't tell you offhand how long that took. It's mostly a question of I/O, though. It's not a question of processing.
Are we looking at hours or minutes?
What did we say? 30 gigs?
It was 31 gigs.
Less than an hour, for sure. Minutes, yeah.
Minutes. Yes, please.
You retrieve only unigrams as far as I can see. What about the bigrams, for example? See, you retrieve only single words.
Right. So the question is, we just considered single words. What about multiple words? So right now, the way we break words is just by using the space as the word boundary. And so we've thought about it, but so far we haven't. So I guess we can, what we can do right now is, if your source word is a phrase like United States, we can definitely repeat exactly what we did and come up with the results. But right now what we don't have is coming up with the tag cloud which contains phrases. That we don't have, because that's a slightly harder problem, and we just haven't thought about it. But if the source word is a phrase, that the same algorithm would work.
Does that XML file, does a copy go out to each of the servers, or does it get split apart?
So that's, I mean, when Hadoop distributes the data, it makes some copies. So it splits the file into blocks, into splits, and then it goes. It keeps some redundancy in the distributed file system. So maybe 3 times the total size.
So the question was just 98 and have another day to work on the project. I think it would be very interesting if you run the algorithm of 2 snapshots of Wikipedia from different dates and then visualize the difference. So you would be able to see what has changed.
Sure. So that would be like a real cloud. It would kind of wave and.
Yeah, I mean, this is just the tip of what you can do with things. I mean, like the combining words together or phrases. There are so many variations to just processing the text itself that we haven't even addressed, which you can spend several years just doing and tweaking this and improving this. Yes, please. Yeah, I think it's 40 words or 50 words, and after that we just
we tried a few variations, and the first variation was considered only 10 word radius, and then I think the last one was 60 word is what we went with. Thank you.